My name is Dr. Amit Kumar, Assistant Professor, National Center of Experimental Mineralogy and Petrology, University of Allahabad. And today we will discuss about the thermodynamic modeling and experimental validation for long-term carbon capture and storage in Deccan basalts, India. Deccan basalt are mainly present in Maharashtra, MP, Chhattisgarh areas. So recently we have experienced one of the hottest summers in the history. And many of you experienced very hot summers, and this is mainly because of the global warming. And the global warming have various effects, which is caused. First one, it is caused by the huge amount industrial uh, usage and melting of ice floes
Amit
and
sir,
forest
sorry to
fires.
disturb you. Could you please turn on your camera, Amit sir? Turn
So
on your
actually,
camera,
my
please.
camera is not working today. So that's why I can use my mobile if you want to see my.
It's up to Dr. Lakshmi. Dr. Lakshmi, what do you say? Dr. Lakshmi, you are unmute. Please unmute yourself.
Already he started, I think, let him continue.
Okay. Please continue.
Okay. So other effects are like forest fire, flood, huge mass floods, and droughts in various regions are the various effects of the global warming which we are facing nowadays. So what is why it is much important and what we can do to limit the effect of global warming. So CO2, it is my research area. CO2 is one of the most important greenhouse gas accountable for the global warming of the atmosphere. Here you can see that in April 2024, the highest record of CO2 in atmosphere was recorded, and that is 426.57 ppm. Okay, and it's a major concern. So we have to do something about that. CO2 is in India have risen at a compounded annual growth rate of 3.1% over the last 3 decades, chiefly due to increase in fossil fuel consumption because we are one of the most populated country in the world. So in past, one report was published by IPCC and which state that global warming of the temperature of the earth was increased by 1.5 degrees centigrade. And if we do not, we are not doing anything, so it will rise accordingly, and we have to face much worse effect of the atmosphere. Like you can see that the at the time of 1980, the effect was very less, but if it increased at this rate, so we have to face the worst effect of the temperature and global warming. So what is geological sequestration? It is one of the most of best option for the long-term storage and to control the increased level of greenhouse gases. To immobilize CO2, geological sequestration was attempted in past also, and it is considered as one of the best option. So there are three types of geological sequestration. First one is hydrodynamic trapping. It means storing these greenhouse gases in the bottom of the ocean, and it will store there with due to the enhanced pressure of the ocean. Okay. Second one is the soluble trapping. It means we can inject the CO2 or other greenhouse gases at supercritical condition in the oil wells from which we can extract the extra amount of oil and store these gases in the subsurface. And third one is the mineral tapping. Here you can understand what is mineral tapping. We industrial pipeline through industrial pipeline we can capture the emitted greenhouse gases and inject it into subsurface where they can, with respect to time, they can convert it into secondary minerals such as carbonates, zeolites, and all. So there are few examples of geological sequestration, especially mineral sequestration in the world, where they uh, show the evidence of successful carbon sequestration in the subsurface. So this is one of the important example. So in India, in case of India, we have one of the largest cover of these such type of rocks, and these are Deccan basalt. And here we can store up to 150 gigaton of carbon dioxide in Deccan traps, and it is already quantified. So these are few photographs of Deccan traps. Here, these are layer type structure, and here you can see that the white proportion mineral within the this outcrop, and it is the evidence of natural sequestration. So we can think about that. If natural sequestration is possible, why cannot uh, uh, replicate the condition and do the artificial sequestration or experimental sequestration in Deccan basalt or rocks of the Deccan basalt? So premises, primary basalt mineral of large igneous province. These are the primary rocks. Are rich in calcium, magnesium, and iron cation, which play significant role in global carbon cycle. Second, basaltic rock provide long-lasting, stable, environmentally favorable condition for CO2 storage. That's why these are more important. Long-term sequestration potentially in Columbia River basalt, Central Atlantic mafic basalt, Newark Basin, and Deccan and Karo basalt. These are the example of one of the biggest continental flood basalts, and in these areas, long-term sequestration is possible. So this is the methodology I followed. We did the thermodynamic modeling, experimental validation, and provided the result of successful carbon sequestration or carbon capture and storage in Deccan basalts. So first one is the thermodynamic modeling. So these are the few example of the recapitulation. In the left side, you can see that these are the mineral which we found in the such type of rocks, such for example basaltic rocks. And when we react the carbon CO, CO2 and enhanced water with these rocks, so secondary minerals will be formed, such as carbonates, silicates, and zeolites. So when we did the thermodynamic modeling using different software such as SUBCAT 92, SUBCAT KLB, and EQ 3 by 6. We can see that the saturation were achieved on different pressure at different time. So, but these are the example of natural sequestration. So, if we want to accelerate the rate of reaction for carbon sequestration, we have to do the experimental work. And these are the work and which was already correlated with the published works. So here we can say that the Deccan basalt or Indian basalt are more or less similar to the Iceland basalt and Columbia River basalt, which were those examples which show the successful carbon sequestration. After that, we did the CCS carbon capture and storage experiments. First, we collected the sample and did the petrography, and after that, we powdered the sample. And this is the equipment. Power reactor is the name, where we did the closed system, high pressure, temperature and pressure experiment at variable pressure, temperature, and time parameters. And this is the sample which we collected after the successful experiment. And here you can see that the bottom part is the you can call it the unreacted basalt sample, but this lighter gray part is the reacted basalt sample, and this is the water sample. So we collected the sample and separated out in the form of liquid and solid. After that, we did the various analysis, and first one is the XRD. So XRD, in the bottom line, you can see that the unreacted basalt, and after that, 50-degree hours experiment, 60 hours experiment, 70 hours experiment. So you can see that the formation of carbonates, for example, calcite in the red color and other carbonate mineral, which was initially not present in the unreacted basalt. So this is the evidence of successful carbon sequestration in Deccan basalts. Besides this, we did the ritual refinement also to determine the crystallographic growth of these secondary form minerals. For example, calcium oxygen bond length was increased in the case of 5 bar PCO, pressure of CO2, and for example, and in case of carbon and oxygen bond length, the growth rate was more or less similar to the previous one. After that, the zeolite mineral, this is the chabazite, is the calcium zeolite mineral, and this is and the form it formed from andesite mineral. This andesite andesine is the primary mineral, and chabazite is the secondary mineral, which was formed due to the carbon sequestration experiment. After that, we did the compared the natural calcite mineral with the experimentally formed calcite mineral, and they are identical to each other. So after that, we can conclude that such type of secondary mineral can also be used for the industrial purpose also, because they are crystallographically identical to each other. Later, we did the SCM photograph micrograph also to determine the to show the growth and how they are formed. For example, this is the example of step growth calcite. Here, this is the zeolite chabazite mineral, tabular siderite, and in the right side, all these honeycomb-like structure are the smectite. These are the clay minerals which form as a honeycomb-like structure on the surface of the grain. And we later compared we did the Raman spectroscopy to further confirm the formation of aragonite, calcite, siderite, and dolomite. All four are the carbonates. And this is the mineral phylogenesis. On different pressure, temperature, and time, how the formation of carbonates, phyllosilicate and zeolite, these are the clay mineral, and these are the zeolite, how they behave and how the formation of these minerals behave with respect to time and pressure. And later, we did the normalized mass loss. This normalized mass loss was done on the basis of the leachate sample collected from after the experiment. So here you can see that initially the uh, uh, concentration of the ions in solution was less because formation of these because these cations are here form the carbonates and zeolite mineral. But in the later case, the concentration is much higher in liquid because there are no formation of the carbonates and zeolites in the residue. Because as you remember, those smectites, honeycomb-like structure smectites, it restrict the formation of carbonate mineral, and due to this, the concentration of these cations are much higher in the later stage. Okay. So we later quantified the uh, present of CO2 mineralization rate on the basis of how much it is formed in the in residue and how much is present in the liquid or leachate. So on the basis of that, we can quantify that the nearly 50%, sorry, 40% of the injected CO2 gas was converted into the carbonate mineral at 100 degrees centigrade temperature and 5 bar PCO2, which is more or less similar to the already those Iceland basalt example. For example, the IC and Stephenson, their formation up to 55% of the CO2 mineralization rate was achieved at 123 days. But here we achieved such rate at 70 hours only. So we can say that our Deccan basalts are much superior as compared to those Iceland basalt and Columbia River basalts. So the chances of carbon sequestration at much faster rate is possible in Deccan basalts as compared to other basalts in the world. So with this, I concluded my presentation.
Good afternoon, everyone. I am Dr. Vinisha Valsaraj P, working as Assistant Professor in the Department of Chemistry, Srinarayana College, Kannur, Kerala. Today, I am going to give a talk on green solvent mediated solution combustion synthesis of photocatalytic active copper-doped zinc oxide nanoparticles and its antimicrobial activity study. These are the co-workers of my study. Outline of my talk is just like this: introduction, characterization, result and discussion, plus the conclusion. In the morning session, we already came to know about the importance of nanoparticle, what is nanoparticle and all. This nanoparticle is nothing but a single unit sized between 1 to 100 nanometer, and they exhibit unique properties like optical, electronic, or mechanical properties. There are wide variety of nanoparticles are present. Some of them are metal nanoparticle, metal oxide nanoparticle, carbon-based nanoparticle, polymer-based nanoparticle, etc. In my work, I concentrated on a metal oxide nanoparticle. It is nothing but metal atoms combined with oxygen atoms. It also possesses unique property. Because of this unique property, it is having a wide variety of application in different fields. Some example for the metal oxides are titanium dioxide, zinc oxide, iron oxides. And here I selected zinc oxide nanoparticle for my study because they exhibit strong ultraviolet absorption and luminescent property. While making use of this property, it can be used in the optical applications, and it possesses strong antibacterial, antifungal activities, which will make them its use in medical field. It's having a wide band gap in the semiconductor region, so useful in electronic device, sensors, and photocatalysts. Its structure is hexagonal wood size structure. And tuning the property of this zinc oxide nanoparticle, we can dope it by another materials like metals or non-metals. So it will enhance or modify the physical properties. So while enhancing this property, it having a broadening their application in various fields. The synthesis method and doping concentrations are the critical for determining the final properties and performance of this nanoparticle. Here in this study, we selected copper as a doping agent because it retains the external structure of this pure ZNO, because this copper having similar ionic radii, and while introducing this copper ion, it can cause a slight lattice distortion which can tune the properties of ZNO, and copper having a high antimicrobial ability. Generally, if we are telling about the preparation of nanoparticles, there are mainly two types of methods: top-down approaches and bottom-up approaches. We all know about this. Still, I am just explaining from bulk material to nanoparticle sizes prepared by that approach is known as top-down approaches. Mechanical milling and lithography is the example for that top-down approaches. Bottom-up approaches is solution, metal ion solutions. We are converted into metal nanoparticles. These are the different methods for these bottom-up approaches. In my work, I selected solution combustion method because it is a simple, cost-effective, and capable of producing highly pure materials. And it is a rapid synthesis process compared with other these materials. In this solution combustion methods, metal precursors are mixed with a fuel and igniting the mixture to initiate the combustion. Here the fuel, we are using the organic solvent. This organic solvent will be very much hazardous to the environment. In our study, we replace this organic solvent into a green solvent, so we can minimize the use of hazardous substance and reduce the waste. Coming to the our work, first of all, the synthesis part. First, the green solvent preparation, that is the plant leaf extract. That plant leaf extract, we used Moringa oleifera leaves for the this purpose. And second one is the ZNO nanoparticle preparation. Solution combustion method is adopted here, and that powder is calcinated at 700 degrees Celsius. Third one is the copper doping. 1 weight percent and 2 weight percentage copper is doped with this nanoparticle, and that also calcinated at 700 degrees Celsius. These are the schematic representation of this procedure. And we did several characterization. First of all, the XRD analysis showed this three material having high crystalline nature, and these are the different 2 theta value corresponding to different plane that confirm the hexagonal Oxide structure of this material. And while making use of Debye-Scherrer equation and this all equation, we find out the different lattice parameters, volume of these materials, bond length, microstrain, etc. From this data, we can clearly see that ZNO and the copper doped ZNO have the same lattice parameters. So it confirms the Oxide structure of this ZNO after doping also. And here you can see that while increasing the copper percentage, the crystalline size is decreasing, and also we can see that the 2 theta value is shifted in the case of higher percentage of copper. But in our study, or we are mainly concentrated on minimum amount of copper is doped with the ZNO. So for this study, we selected 1% copper ZNO for ZNO. UV visible diffuse reflectance spectroscopy used to characterize the optical property. Here you can see that there is a absorption range for 250 to 367 nanometer for ZNO, and while 1% copper ZNO having 250 to 387 nanometer, and there was a peak at 360 nanometer in the case of ZNO. That is mainly due to the surface plasma resonance, and that is shifted in the case of copper doped to 380 nanometer. This surface plasma resonance peak is shifted mainly because of this. There are 2 types of metal ion present in that. While making the use of talk plot, we find out the band gap of ZNO, that is 3.1 electron volt, and 1% copper ZNO is 2.7 electron volt. We can see that while copper doping, the band gap is decreased. The decreasing the value of this band gap is mainly due to the difference in the electronegativity of copper, and also the PD spin exchange interaction between the band electrons and the localized d electrons of the transition metal ions substituting Cu2+. We characterize the material with the Ramesh spectroscopy, and here we can see that the different vibrational modes of this material, and this indicate the good wood side structure of pure and doped Sedeno material, because there is no wave peaks corresponding to the vibration modes of copper, copper oxides, etc. So that confirms the successful doping of this copper into the lattice of the Sedeno. This is the morphological study. We did the SEM EDAX, and EDAX also confirmed the 1 weight percentage of doping in the Sedeno. And while knowing the photocatalytic ability of this material, we did the dye degradation study using 110 ppm methylene blue solution. The batch adsorption technique was adapted for this study, and it is irradiated for 3 hours in the visible light. And at a different time interval, we selected collected this methylene blue and recorded the absorption spectra. And this is the percentage degradation finding out equation. Using this equation, we find out the different percentage degradation ability of Sedeno and copper doped Sedeno at a different time interval, and see that copper doped Sedeno having high percentage of degradation. Mainly it is because of while doping with the copper, this band gap is narrowing. This also already confirmed in a talk plot, and that reduces the recombination rate of electron hole pair, and also the creation of hydroxyl radical that due to the electron pair migration to the surfaces. Just for knowing the antimicrobial ability of this material, we studied well diffusion method, or we adopted a well diffusion method for this antimicrobial study. We selected gram positive bacteria and also gram negative bacteria. Gram negative bacteria is E. coli, and gram positive bacteria Staphylococcus aureus. These are the photographic images of the Sedeno and 1% CU Sedeno. And tabulated inhibition zone here. Here we can see that 1% copper Sedeno having high activity towards this gram positive Staphylococcus aureus. The difference in this is mainly because the structural difference of this gram positive and gram negative bacteria. Gram negative bacteria having outer membrane. This copper doesn't have an ability to or damage the cell membrane, but it can bind the DNA molecules and disrupt the helical structure in the case of gram positive bacteria. And also it produces different radicals, hydroxyl radicals, superoxide anions, and these will also help for the damaging the bacteria. So while coming to the conclusion part, successfully doped zinc oxide with copper using solution combustion method, using green solvent, and using XRD, we measured the crystalline parameters, and it confirmed the Morse structure of these Sedeno and also copper doped Sedeno, and it is the D crystalline size is around 30 to 40 nanometer, and the band gap is decreased in the case of copper doping, that is studied using DRS and with the help of dot plot. EDAX and the Raman spectroscopy study shows the successful doping of copper on zinc oxide. Photocatalytically active materials were demonstrated using methylene blue dye degradation. It has shows an enhanced ability towards this methylene blue dye, and antimicrobial activity show high activity towards gram positive bacteria. Thank you.
Working. My area is actually I deal with the wood. We belong to the Indian Council of Forestry Research and Education. As it tells, we are dealing with the forestry species. I belong to the Institute of Wood Science and Technology, which comes under ICFRE, located in the Bangalore. Here in this institute, we mainly work on wood, different aspects of wood, like utilization of the wood, seasoning of the wood, preservation of wood, and different eco-friendly preservation development. So in that line, my topic was evolution of coconut shell pyrolytic oil distillate as a wood preservative for the industrial application. See, we know that wood is a biodegradable material, and it was degraded by many organisms such as insects as well as fungi. But over the period of time, many chemical preservatives are used. As the world is changing, or it is shifting towards the eco-friendly preservatives, wood industry is also trying to find different alternatives. One of them, those alternative was coconut shell pyrolytic oil. Coconut shell is widely available in India, and it is a material which is not easily eaten by the termites. The study was evolved with the one fact that whenever many materials are dumped in the dump yard, all the wood materials or other materials will be eaten by the termite. But the coconut shell was not eaten. So thinking that we wanted to know what was the thing which makes this coconut shell resistant to the termite. As a result, we found that there is a byproduct which is a coconut shell pyrolytic oil which will be produced by gasifying the coconut shell. See, in this line, we actually worked since 2001 as the project was supported by Kerala State Educational Transportation and DST. We actually worked and we also developed a wood preservation formulation and which was tested as per the BIS standard. For any material, wood preservative to apply accepted in the industry as a wood preservative, it has to be tested as per the BIS standard. For different materials, there are different standards. Accordingly, for the wood, BIS standard is, for the preservation, BIS standard is 4833. See, although we developed the preservative, the main challenge was the acceptance of this particular product in the industry. We actually tried with the coating industry. Coating industry means it's a kind of coating which will given to the wood. What we found is that there is a problem with the emulsification. It is not properly mixing. And another major industry related to wood is plywood industry, plywood or the panel product industry. We wanted to use this product for these two industries so that there will be a maximum utilization of this particular project. See, I'll explain you how we prepared this. The coconut shell pyrolytic oil, which comes as a byproduct of coconut shell, liquefaction is actually a dark color viscous liquid. It is similar to that of the coal tar, which cannot be directly used on a wood. Although it has a very good preservative properties, but the aesthetics of the wood will be compromised. So we have to distill that coconut shell pyrolytic, and when we distill, we'll get the coconut shell pyrolytic distillate, which is actually a colorless solution. This colorless solution, when we remove that viscosity, is not very effective. So the thing is, we have to mix with some inorganic salt. We tried actually different materials like copper sulfate, which act as a fungicide, zinc chloride, and the boric acid, which act as a insecticides. In case of food, fungus and the insects are the main agents of degradation. We also use copper sulfate and zinc chloride combination. The thing is, the original liquid was viscous black color. The distillate was colorless, and we have to check the solubility. After the solubility of this particular component or the inorganic salt, it converted into bluish green color or the colorless liquid. The best one was copper sulfate along with the copper sulfate. So this is how the formulation looked after the mixing of the inorganic salt. In true sense, we actually prepared two formulations. Along with that, we used the coconut shell pyrolytic oil distillate. The first part of this thing is we have to treat this material with the wood. Initially, we have to prepare the wood. We have to take the wood. We have to weigh the wood. We have to do the treatment. The preservative treatment, which is mostly followed, is of two types. One is dipping treatment, which is a surface treatment, and a small amount of penetration will be there, or else a preservative treatment. In the preservative treatment, preservative liquid will be put in the pressure treatment, under which, under the pressure and the vacuum, preservative will be made to enter inside the wood. This preservative treatment gives through and through treatment. A complete penetration will be there. Hence, the preservative treatment is most considered treatment in case of wood. After the treatment, we have to season the wood. We have to keep for the conditioning. We have to allow it for the drying. This is how we allow it for the drying. Below each stake, we have to give some space and stake it one above the other. The first test which was prescribed for the wood preservation is called as graveyard test. As per the BIS 4833, any wood preservative which will be used has to undergo this test and it has to prove good. Then only we can accept this. And it is field experiment. The lab experiment cannot be done for, is also there as per the ASTM standard. But in case of India, it is only a field test which were recommended by the BIS. If it passes the field test, then only it can be accepted. The BIS clearly tells that field experiment should be conducted in 6 places falling in different agroecozones of India. For the preservative treatment, we always use heavier basilensis or the rubber wood as a test sample. The reason behind using rubber wood is it is highly susceptible to fungus as well as for the insect. What we did was, as per the standard, we have to take the stakes of the measuring of the size 35.8, 3.8 and 3.8 centimeter. These stakes has to be selected from different wood blocks so that the pseudo replication can be avoided. We have to consider pure hardwood, avoiding any sapwood and the pith. The stakes which we are selecting should be free from any insect damages or fungal attacks. After the stakes, we have to keep the stakes in 80 degrees Celsius to get the constant weight. After this, these stakes will be used to treat as per the dipping method or using the preservative method. After this, we have to implant the wood in a soil along with the control. Control is without treatment, whereas others will be treated with the one or the other different chemicals. This test is particularly called as graveyard test because, like a graveyard or the cemetery, we are going to half bury the wood inside the ground at the distance of 1 feet apart from all the direction. Usually we follow the random design of keeping the control samples as well as for the test samples. For our study, we selected the field trials at Hyderabad, which is tropical wet and dry, Jodhpur, which is the arid region, Palod, tropical wet, Nallal follows under the semi-arid condition, Prayagraj, humid subtropical, Vishakhapatnam, we did it in tropical wet dry condition, but again coastal. Other than that, we also did it in the highland, but those results are not shared here, as still those studies are further continuing, and till this level we could not get the result. After the implantation, in this case, the observation will be visual rating. Every 6 months, we have to go remove the stakes and we see what is the kind of infestation which is there. Depending upon the level of infestation, we have to assign the points. It will be mostly qualitative assessment, not the quantitative one. Like if the wood is very sound and without any attack, the point will be assigned is 10. Whereas if more than 50% attack is there, then it is considered as a 4, or the total failure, 0 points will be given. These are our field testing sites where we actually inoculated the test samples. See, before understanding how the results work, it is important to understand how the wood durability is classified. As per the BIS standard 401, wood durability, let it be natural durability or any kind of durability, will be classified in under 2 classes. Actually 3 classes. Class 1 is actually highly durable timbers, where the teak or the other kind of wood falls. In this condition, in a graveyard test, the wood has to be remain intact for the 120 months. That is almost 10 years without any fungal or termite attack. The class 2 timbers has to remain intact in the soil for around 60 to 120 months. Whereas the class 3 timbers has to remain intact for the 60 months of period. And if below 60 months any wood are degraded, those woods are considered as perishable or the non-durable woods. And these are the categories. Perishable or the non-durable woods are the woods where we actually need preservative. Hence, the wood, Hevia brasilensis or the pinus will come under this category, which are perishable or the non-durable. When we treat this particular perishable wood with any wood preservative, if it resists the biodegradation for the 36 months, then only it is considered that wood preservative is working and it is effective. So now I am telling the results of our test. We actually did the test at Nallal and other areas as per the agroclimatic zone. In the Nallal, we did lots of work because it was very close to our regular laboratory, and we could go every month and we could see the samples. See, we tested four things: CSPO, CSPOD, along with the copper sulfate, along with the copper, zinc, and the boric acid. We found that coconut shell pyrolytic oil, the treated woods with the dipping method and the pressure methods all underwent degradation within 6 months. As also the control sample, which were not treated, underwent the degradation within 6 months. Whereas the distillate, coconut shell pyrolytic distillate, provided this protection for small amount of time. In case of dipping, it is 9 months, and in case of pressure method, 12 to 15 months, the samples or the stakes treated with the CSPOD remained intact. Whereas the stake treated with the copper sulfate and CSPOD mixture, they showed in dipping method, deterioration was 10% after 21% and 20% deterioration after 24 months. Whereas in case of pressure treatment, even after the 36 months of the field trial, the test samples remain intact. In case of zinc, along with the zinc and copper sulfate also, we found the similar result. Even after the 36 months, the samples were intact. We also studied at the different regions. In this region, we could not. So far, we haven't completed the 24-hour study. We are still at the 24-hour study only. Still, we have to wait for another more year. Here also, all the control samples were deteriorated within 6 months. Whereas treated samples with the CSPOD deteriorated within 12 months, whereas other samples remain intact even after 24 months. See, if preservative, when we are talking about the industry always looks about the shelf life or the stability of the preservative, which means it can store for the longer time. It's not like that whenever you have the wood to be treated, you will buy the preservative. Company will buy the preservative at once and it stocks it, it keeps its stock. So we have to look into the shelf life of the preservative form. So what we did was we kept these samples for the duration of different months, like 3 months duration. After preparation of the formulation, we kept initially for the 3 months, 6 months, 9 months, 12 months, and the 15 months. For these samples, we again treated. After the 3 months, we took the sample, we treated the wood with the sample.
Ma'am, I think your time is up. Please, I can try to conclude. Sorry for the interruption. Yeah.
So we continued the research like that, and we found that even after the 15 months, the shelf life of the preservative formulation was intact. The next was preservative. Next, we have to try it for the plywood. In case of wood, you can use the preservative directly, but in case of plywood or the panel product is the glue line treatment. Plywoods are made with the adhesive material, which is actually PF resin or the UF resin, mostly used in the industry. We mix this preservative along with the glue line, and we use with UF preservative and the PF resin. We prepare the concentration of 1%, 2%, and the 3%. For the UF resin, pressing parameters were temperature of 105 degree with the specific pressure of 10 to 12 kg, and the pressing time is equals to thickness of the ply. Whereas in case of PF resin, temperature was 145 degree and the pressure was 14 to 16 kg kilometer. Whereas the curing time was 7 meter plus 4 meter of the thickness of the ply. After that, we have to see the bonding. In case of plywood, what makes the difference is if the preservative mixed with the properly with the resin, then only it is considered as the good preservative. But what we found that we use Melia dubia and Elianthus mulbarica for the preparation of the plywood, as these are the two major species which are used in the preparation of the plywood. We found that this material was not compatible enough with the glue line. In case of UF resin as well as for the PF resin, this particular preservative was not compatible. So I can conclude that we can use this particular preservative for the wood, but not for the plywood at this particular time. We have to still more work on this particular plywood. We have to change the resin system. Then only we can use this preservative for the plywood or the panel wood industry. Thank you.
Yeah, the topic of the presentation is an environmental protection through organic dissipation into admirable activated carbon employed in day-to-day utilization. You have 8 minutes, ma'am, and you please stick to the time. Now you can start, please.
Yeah, good afternoon, everyone. My name is Soumya. Thank you for being here. Today, I am going to present about an environmental protection through organic dissipation into admirable activated carbon employed in day-to-day utilization. Here, I have chosen lemon peel. Lemon peel, until recently, were largely considered as waste product resulting from the consumption of lemon. By diverting these peels from landfills and transforming them into activated carbon, we can not only reduce the waste accumulation, but also contribute to a circular economy by reusing a valuable resource. Activated carbon produced from waste peels are used as absorbent to remove organic compounds from the natural environment. Some of the properties of activated carbon are: it is less expensive, it has a good stability, it has a good surface area, it has a good pore structure, it has good electrical conductivity, it is resistant to acidic or basic medium, and it is also stable at high temperatures. Some of the common application of activated carbon are: it is used in food industry, pharmacy, drinking water treatment, gas purification, air purification, automobile industry, food industry, for dyeing purpose, etc. Why I have chosen lemon peels is it is good absorbent, it is easily available, and it is also a solution for dealing with disposal. Environmental pollution can also be controlled. How do I synthesize LPAC? LPAC means lemon peel activated carbon. Here we have followed 2 steps, which is carbonization and activation. Lemon peels were first washed with DI water and it was dried. It was sun-dried. Then the dried peels were carbonized for varying lengths of time, like 300 degrees centigrade for 1 hour 30 minutes, 2 hours, and 2 hours 30 minutes. Then the carbonized samples were milled. Then the milled samples were kept for activation under 400 degrees Celsius for 15 minutes. Then it was taken out and it is grinded finely. The XRD analysis of 3 samples. In the figure itself, we can clearly visible that LPAC carbonized under 300 degrees Celsius for 2 hours 30 minutes. It has 2 peaks at 24.11 and 28.25, which lines up with the lattice planes at 002 and 420. The graphitic carbon, it is given in the figure. At 300 degrees Celsius for 2 hours 30 minutes, the crystalline character at 420 is improved, and the amorphous nature is also evolved. Additionally, the nanoparticle size was calculated using Debye-Scorer formula, and the calculated grain size was 35.67 nanometer. Then the FTIR analysis. The 3 different temperatures of 1 hour 30 minutes, 2 hour 30 minutes of 300 degrees Celsius carbonized sample were shown. Functional groups are seen in the activated carbon from lemon peel. In 2 hour 30 minutes samples, the activated carbon has been treated with contains more hydroxyl group and carbonyl functional group at 884, 407, 2986 and 3280. The functional group hydroxyl and carbonyl functional group has increased then compared to the other 2. FESM, morphological studies reveals that the lemon peels carbonized under 2 or 30 minutes is given a good porous image, which is shown in the figure. A is 1 hour 30 minutes, B figure is 2 hours, and C figure is 2 hours 30 minutes. We can visibly see the porous structure is improved while the sample is carbonized for 2 hours 30 minutes. And below DEF shows the EDX image, ADAX image of these 3 samples, which shows the presence of carbon and oxygen. Then we are coming to Raman spectroscopy. The amount of carbon that has been graphitized was determined with the help of Raman spectroscopy. The G and G band, which stands for disordered carbon, which is observed in Raman spectra. The ratio of lemon peel activated carbon under 2 or 30 minutes is 0.89, which is comparatively high than the other 2. Then we have taken contact angle studies to measure its wettability. the lemon peel carbonized under 2 or 30 minutes has an angle of 93, and 1 or 30 minutes has an 125, and 2 hours has 112 degree, which is super hydrophobic. 93 is also not fully hydrophilic, but it is comparatively more wettable while comparing the other two. Then the dielectric properties of 3 samples has also been calculated. Based on the dielectric measurement, at lower frequencies, the dielectric constant exhibits a significant increase. As the frequency increases, the dielectric constant gradually decreases. Lemon peel activated carbon carbonized under 300 degrees Celsius for 1 or 30 minutes, 2 hours has an dielectric constant saturates at 1 Hertz, and for 2 hours saturates at 2 Hertz. For 2 hours 30 minutes, the lemon peel activated carbon is saturates at 3.5 Hertz, indicating that higher carbonization leads to higher dielectric constant. Then I would like to conclude. An environmentally friendly method that eases the burden of bio-waste disposal is turning into activated carbon. At 300 degrees Celsius for 2 hours 30 minutes, lemon peel activated carbon confirms the graphitic carbon structure. FTIR analysis reveals an increase in functional group. Morphological analysis reveals that highly porous structure at treated at 2.5 hours, which explains good absorption capacity. The existing of graphitized carbon is explained by Raman spectrum. Its hydrophilic nature has been successfully attained, which is measured under the contact angle. Its protection process utilizes absorbent agriculture waste and transforms into highly absorbent material with excellent properties. The diverse application of lemon peel activated carbon or wastewater treatment, air purification, gas purification, soil remediation showcase its prominent, diverse economic and addressing environmental pollution. Thank you.
Please continue.
My introduction. Current study focusing DC glow discharge plasma used to activated carbon, characterized by XRD and FTR Raman spectroscopy and FESM and EDS highlights to structural and functional improvements. The experiment section, the RHAC production and DC glow discharge plasma treatment. The material sourced from rice husk, sourced from local mills in Tamil Nadu in India. It was dried using sunlight to remove the moisture and washed with distilled water, eliminate the pollution. The rice activated carbon preparation method. The rice is pyrolyzed at 400 degrees for 1 hour. The produced charcoal. The charcoal crushed into nanoscale using a mortar and activated at 500 degrees for 2 hours to create the activated biochar. The DC glow discharge plasma treatment used to different gaseous plasma, air and oxygen plasma treatment used to prepared oxygen plasma treated RHAC and air plasma treated RHAC prepared. The XRD analysis of activated carbon, the peak identified, the peak phenomenal peak 24 degree, which indicates graphite 002 plane, suggesting parallel graphene sheet stacking. The minor peak at 44 degree represents 100 planes of graphite antipated to sp2 hybridized carbons. The effect of plasma treatment. The plasma treatment enhanced structural characteristics of activated carbon as indicated by increased peak intensity in XRD, likely due to incorporation of oxygen and nitrogen groups, thereby suggesting potential improvement in electrochemical performance and surface functionality. The FTIR analysis of activated carbon, the peak at 3,359 centimeter per minus 1 and 1,703 centimeter per minus 1 correspond to the OS stretching vibration. And 2,344 centimeter per minus 1 indicated NH3 stretching vibration, and presence of Allen group observed at 2,100 centimeter per minus 1. The minimal C double bond stretching vibration noted around 1,200 centimeter minus 1. The peaks at 1,600 and 1,400 and 1,045 centimeter indicate NH splitting, C oxygen bending, and C nitrogen amine bonds bending observed. The silicon and oxygen bond around contributed peak at 800 centimeter per minus 1. Will C hydrogen bond bending up is 670 centimeter per minus 1. The closed plasma treatment, the intensity of these functional groups significantly increased, indicating the unconventional functional group attachment. The Raman analysis of activated carbon, the G band up centered at 1,605 centimeter per minus 1 with E2G symmetry, typically crystalline graphite. D band approximately 1,620 centimeter per minus 1 overlapping with G band, indicating disorder in graphite structure. Two strong dimensional screw Strong two-dimensional signal at 2720 centimeter per -1, indicating stacked graphene layers. And contact angle analysis. RHAC surface hydrophilic nature changes were observed in shown figure. The untreated RHAC has a 74-degree contact angle initially. The after oxygen and air plasma treatment, contact angle reduced significantly. The air plasma treatment lowered the compared oxygen and untreated RHAC. The reactive air plasma introduced nitrogen and oxygen species, etching carbon and adding the hydrophilic groups, making the surface more water friendly. The surface and elemental analysis of RHAC. The air plasma treatment enhanced the surface roughness and porosity of RHAC compared to untreated RHAC. The heat treatment significantly affects the product structure and particularly influenced by plasma treatment. Air plasma treated RHAC exhibits more extensive network structure with larger pore on the walls. The error spectrum and color mapping given presence of in RHAC, carbon and oxygen nitrogen groups. Cyclic voltammetric analysis. The figure displays voltochrome showing current responsive to applied potential with distinct peaks indicating reduction and oxidation process, suggesting electrochemical reaction. The specific capacitance of with scan plate showing the values of RHAC at lowest candidate 910 Faradic per gram, at higher candidate 482 Faradic gram per. For air plasma treated RHAC, for low candidate 1298 Faradic gram per, and highest candidate 930 Faradic gram per lowest candidate. The specific capacitance and area under the curve indicate that air plasma treatment improves the RHAC characteristics as oxygen and nitrogen functionality, enhance charge storage capacity and electron transport property. The GCD analysis, longer charging time and shorter discharging time indicates RHAC strong capacitive property and low internal resistance. Irregular discharge curve and asymmetric charge point suggests complex electrochemical mechanism within the electrode. The specific capacitance values of unmeasured RHAC 223, 189, 178, and 142 and 109 for Faradic gram per respective current density, and air plasma treated RHAC 424 and 371, 330, 272, and 172 Faradic gram per respective current density, and oxygen plasma treated RHAC 277 and 240 and 221, 169 and 120 Faradic gram per respective current density. The final EAS analysis, air and oxygen plasma treatment increased polarization resistance slightly compared to untreated RHAC within values of 0.91 and 0.8 ohm respective versus 0.6 ohm for untreated RHAC. The charge transfer resistance decreased after closed plasma treatment, 5.63 ohms for air plasma and 5.43 ohm for oxygen plasma treatment. The RHAC compared to 6. For untreated RHAC. The final conclusion, the effect of plasma treatment, the oxygen and air plasma treatment enhanced RHAC electrochemical properties and surface characteristics and improved surface properties. The plasma treatment added functional group and increased disorder in carbon structure, enhancing surface interaction, enhanced hydrophilic nature. The air plasma treatment notably increased RHAC hydrophilic nature and electrolyte interaction capability. The electrochemical performance, impedance spectroscopy revealed reduced resistance 0.1 ohm, will cyclic voltochrome showed higher specific capacitance 1298 Faradic gram at 5 millivolt per second. Charge discharge cycle. Air plasma treated RHAC exhibit improved energy storage capacity 424 Faradic gram at 3 amps per gram in GCD analysis. Sustainability and promise. The RHAC treated with air plasma demonstrated superior performance, highlighting its potential as a sustainable energy storage material for using agriculture waste.